So the question is explain the LoRa Standardization and Alliance, MAC layer, which is asked for 8 marks in the July-August 2022 question paper. So it consists of 2 marks. We have to explain the standardization and alliance as well as the MAC layer of the LoRaWAN. So let us give 4 marks for the standardization and alliance and another 4 marks for your MAC layer. Okay. So to begin with, what is meant by a LoRaWAN? It is an unlicensed band LPW. What is meant by unlicensed band? We don't have to give or make any payment for using this unlicensed spectrum. So it is an unlicensed band LPWA, that is low power wide area technology. Moving on to your standardization and alliance. LoRaWAN is optimized for long range, two-way communication. So what is meant by two-way communication? Uplink as well as your downlink. Uplink means from your endpoint, that is devices, to your server, and downlink means from the server to your endpoint or your devices. And low power consumption, the technology evolved from layer 1 to a broader scope through the creation of your LoRa Alliance. Okay, so by means of your LoRa Alliance, the technology has evolved into a greater, broader scope. The LoRa Alliance quickly achieved industry support and currently has hundreds of members. The LoRa Alliance uses the term LoRaWAN to refer to its architecture and its specification that describe the end-to-end LoRaWAN communications as well as your protocols. Now basically this is your, you can put the diagram of your high level overview of your high level LoRaWAN different layers. So it starts off with the base layer, which is supported by your LoRa Alliance, which is supporting your unlicensed spectrum, which consists of 868 megahertz, 915 megahertz and other regional bands, above which you have the LoRa physical modulation, which is supported by SEMTech or semiconductor technology. And above that you have your LoRaWAN MAC layer, which is also supported by your LoRa Alliance. And above that you have your different application protocols. So what are the different protocols we are using in the LoRaWAN? So we have a COAP, which is nothing but your constrained application protocol, and MQTT, which is message queuing telemetry and transport protocol. Then we have IP version 6 or 6, that is 6 stands for IP version 6, low power wireless personal area network, raw protocol and other protocols, above which we are going to build your different applications. So we have different 1, 2, 3, 4, 5 layers. So your base layer is supported by your LoRa Alliance, whereas your LoRa physical modulation is supported by your SEMTech, and LoRaWAN MAC is supported by your LoRa Alliance. So you can write these points for your standardization and alliance. So moving to our MAC layer, the LoRaWAN specification documents 3 classes of LoRaWAN devices. So the devices can be classified into 3 classes, that is your class A, class B and class C, which basically explains the method in which the communication is taking place. Okay, so what is meant by class A type? This class is the default implementation. It is basically optimized for the battery powered nodes. Okay, so battery powered nodes, it allows bidirectional communication. What is meant by bidirectional? Again, both your uplink as well as your downlink communication, where a given node is able to receive downstream traffic after transmitting. Okay, so 2 receive windows are available after each transmission. So 2 receive windows is available. Say for example, after the transmission you have 2 windows for your downlink. Okay, so for a two receive windows are available after each transmission. So that is the peculiarity of your class A type. Moving on to your next type. So the next type is your class B. This class was designated experimental in LoRaWAN 1.0.1 until it can be better defined. So what is the specialty of class B? The class B node or endpoint should get additional receive windows compared to class A. So in class A you had 2 receive windows, right? So say for example, in class A you had 2 receive windows. Now you will be having here additional windows also in the case of your class B type. Okay, but gateways must be synchronized through a beaconing process. Okay, and moving on to your class C, this class is particularly adapted for powered nodes. It is not battery powered, it is powered nodes. This classification enables a node to be continuously listening by keeping its receive window open when not transmitting. Whenever it's not transmitting also, the receive window will always be open for continuous or continuous listening. Okay, then we can write the MAC frame format. So this is one of the example of your MAC frame format, which consists of three fields. One is your MAC header, MAC payload, and your MIC, that is your message integrity code. Okay, so LoRaWAN messages, either uplink or downlink have a physical payload composed of, so it consists of, basically it consists of a payload, right? Payload as well as your header. So here in this case of the physical payload consists of 1 byte MAC header, a variable byte MAC payload, and a MIC, that is 4 bytes. That is, if you can see the figure, 1 byte MAC header, which is also called as MHDR, then a variable byte, that is MAC payload, and 4 bytes message integrity code. That is, the message should not be modified, right? So it is kept track by means of your message integrity code. The MAC payload size, that is your MAC payload size, depends on two quantities. That is, it depends on the frequency band as well as the data rate, the date at which the data is being sent. So two factors determines your what is your size of your payload. One is your frequency band and the other is your data rate, ranging from 59 to 230 bytes for 863 to 870 megahertz. So 59 to 230 bytes for 863 to 870 megahertz and 19 to 250 bytes for 902 to 928 megahertz. That is for your unlicensed frequency band. Okay, now moving on to the next slide. Basically, your LoRaWAN utilizes 6 MAC message types. Okay, so what are the 6 message type? First one is your join request. Second one is your joined accept message. So join request, joined accept. Third one is your unconfirmed data up and down message. So you will be having unconfirmed data up message. Then you will be having unconfirmed data down message. Then confirmed data up message and confirmed data down message. Then you have uplink messages and you have your downlink messages. So let me start with your uplink and downlink messages. You know that uplink messages, as I have explained, the messages that are sent from the endpoints to the network server. So uplink means from the node to the server. Okay, so this is your device or your end node to the server. It is called as your uplink, and if it is vice versa, that is from server to the end node, it is called as your downlink. So downlink messages flow from the network server to a single endpoint and are relayed by only a single gateway. Okay, so what is meant by your unconfirmed data up and down message means that unconfirmed means we don't need an acknowledgement signal. But whereas in the confirmed data, once the data is transmitted, the receiver has to send an acknowledgement. If an acknowledgement is present, then it comes under the category of your confirmed data up down message, a message that must be acknowledged. Okay, so what is meant by join request? Over the air activation and joining the network. That is, in order to join the network, you have to give a request and accept message after accepting. That is the over the air activation and joining the network. So request as well as accept messages. Okay, so the LoRaWAN endpoints are uniquely addressable. Now we are talking about the last point is about the addressing. Okay, how it is being identified. So addressable LoRaWAN endpoints are uniquely addressable through a variety of methods. So what are the different methods in which it is addressable? An endpoint, that is, endpoint means nothing but the device can have a global end device ID. Global End Device ID or DAVE EUI, represented as IEEE EUI 64 address, or an endpoint can have a global application ID. Either it can be having a global end ID, that is called as DAVE EUI, and global application ID or an app EUI, represented as an IEEE EUI 64 address that uniquely identifies the application provider, such as the owner of the end device. Okay. So in a LoRaWAN network, endpoints are also known by their end device address. It is known as your DAVE address, which is a 32-bit address. Okay. So this among this 32-bit address, the 7 most significant bits are the network identifier, which will identify the LoRaWAN network, whereas the remaining 25 lower significant bit are used as the network address to identify the endpoint in the network. So these are the 3 different ways in which the LoRaWAN endpoints are addressable. So you can split it into 4 marks for your standardization and alliance, and another 4 marks for your what is that, MAC layer, and totally we can get your 8 marks for the question.